Okay, so today we're going to continue in our computation unit with decimals to go along with Common Core State Standard 5 NVT 7, to add, subtract, multiply, and divide decimals to hundredths. And today we're going to focus on multiplying decimals. For the first lesson in multiplying decimals, we're just going to focus on multiplying a decimal times a whole number. So let's go back and review the parts of a multiplication problem. What you're usually told is that a multiplication problem has a factor times another factor, and that will equal a product. There are other words that you can use as well. These are not as commonly used, at least not until you get a little bit older. The first number in a multiplication problem is called the multiplicand, and the second one is called the multiplier. The multiplicand is the number that is being multiplied together, and the multiplier is how many times that's happening. And again, it equals the product. The reason you don't see these two words that often is that the commutative property of multiplication does apply, which means that 5 times 3 is the same as 3 times 5. So since the numbers are interchangeable, they just figured to go ahead and stick with one common word, being factor, to describe both of the numbers in a multiplication problem. So if we had the problem 23 times 257, we know we would line it up vertically, one factor on top of the other, and then when we got done, we would have a product. Now, when the problem is presented to you like this, 23 times 257, a lot of times I'll see where students want to put the 23 on top and the 257 on the bottom, like it's a subtraction problem. The first number always goes on top. But remember, multiplication is commutative. This arrangement for multiplication with the smaller number on top, many students find it difficult to know what to do when they get to this third digit down here, this 2, and so they end up getting a problem wrong when they know the steps to multiplying by two-digit numbers. So my advice is always put the bigger number, the number with more digits, on the top, and then the smaller number underneath, and that way you're very much more likely to get the problem correct. So when we also learned how to multiply, way back when, we learned that multiplication was repeated addition. Again, the first number, this would be the multiplicand. The second number is the multiplier. The multiplicand is what's being multiplied or added together for the repeated addition, and the multiplier is how many times. So 15 times 3 would mean 15 plus 15 plus 15 again. When we work this out, 5 plus 5 plus 5 is 15, carry the 1, and we get 45. So we know that 15 times 3 is equal to 45. So let's see what would happen if we introduced a decimal into the mix. So instead of 15, we're going to have 1 5/10 times 3. Well, again, that's going to mean 1 5/10 plus 1 5/10 plus 1 5/10. We just finished how to add decimals, so we know what to do to add this problem. We line them up by their decimal points, and then we simply add like they're whole numbers. So if you'll notice, the number part is identical. Here we have 3/15 and the sum is 45. Here we have again 3/15 if we're just looking at the number, and the sum is 45. We know when we add decimal numbers that the decimal point comes straight down. So my answer would be 4 5/10, so that 1.5 or 1 5/10 times 3 is 4 5/10. So I know that a lot of times repeated addition, especially if the second number or one of the factors in the problem is a larger number, isn't necessarily an ideal strategy. So we are going to take a look and see how do we move this repeated addition strategy into multiplication. Well, if we write the problem just like it's a regular old multiplication problem, we can still do the multiplication just like they were whole numbers. Okay? So 5 times 3 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. And you'll notice from the last slide that we knew the answer to this problem was 4 5/10, so that means that the decimal has to go there. Okay, let's take a look at another one. This time we have 7 and 28 hundredths, and we're going to multiply that by 6. Again, according to the repeated addition idea or strategy, we would line up the problem this way. We'd have 6, 7, and 28 hundredths lined up vertically, and we'd have to add all that together. Well, I'm not one that's a big fan of repeated addition. I do know that no matter what I get, when I add decimals, my decimal point comes straight down, which means that I should have 2 numbers behind the decimal and then however many numbers in front. But I'm going to go ahead with the multiplication strategy, knowing that my decimal point is going to have 2 numbers behind it. So 6 times 8 is 48, carry the 4. 6 times 2 is 12, plus 4 more is 16, carry the 1. 6 times 7 is 42, plus 1 is the 43. And I know from looking at my repeated addition model, the decimal point has to go in between the 3 and the 6 because I have to have 2 numbers behind the decimal point. So what did you notice about these problems? Well, one thing that I noticed is that if I have 1 number behind the decimal or a number in the tenths here, and my answer, I have a number in the tenths. In this second problem, if I have 2 numbers behind the decimal point, making this hundredths, I'm going to need 2 numbers behind the decimal point, making it hundredths again. And that goes back to the multiplication as repeated addition strategy and knowing that your decimal point comes straight down when you add. So let's take a look at 2 example problems. We'll work through them and see what we come up with. So the first one is 35 and 48 hundredths times 8. And when I write that problem, it's going to look like this. And again, I'm going to just multiply. 8 times 8 is 64, carry the 6. 8 times 4 is 32, plus 6 is 38, carry 3. 8 times 5 is 40, plus 3 is 43. And 8 times 3 is 24, plus 4 is 28. And remember, if I have 2 numbers, if I have hundredths in my problem, my decimal point is going to go right there so that I have hundredths in my answer. Okay, and let's try one more. So I'm going to line up the problem like this, like it's a regular multiplication problem. This time I'm working with 2 digits, and you'll notice the first number only had 2 digits, but the second number had 3 digits, so I reversed that so that it looks a little bit more normal. All right, I'm going to start by doing 4 times 8, which is 32. Then I do 4 times 1, which is 4, add 3 more, 7. And 4 times 3 is 12. When I drop to my second line of multiplication, remember I have to start at that 0 to hold the place. And then I'm going to multiply by my 2. 2 times 8 is 16. Carry the 1. I replace that 3 I carried with the 1. 2 times 1 is 2, plus 1 is 3. And 2 times 3 is 6. Now I know that I have to add those 2 partial products together. 2 plus 0 is 2. 6 plus 7 is 13. Carry 1. 1 plus 2 is 3. 3 more is 6. And 1 plus 6 is 7. Looking back at my problem, I have a number that's in the tenths place. So in my answer, I should have my decimal point so that I have a number in the tenths place. Okay? So now after this, I want you to go and try some of those practice problems. The first time through, you're just going to be looking to see where does the decimal point go, and we'll go from there.